Welcome to Ask and Learn.
All right, hey guys, we're going to be doing problem number 68 in chapter 5 of Chemistry Central Science. So this is a two-part question. Part A, they want to know, what's the value of the standard enthalpy formation for an element in its most stable form? The answer to that is 0. The delta H formation of any element in its standard state at standard conditions is always going to be 0. So oxygen is not found as monatomic, it's found as diatomic O2, so it's always going to have a delta H of 0. Similarly, a delta H for F2, which is fluorine's in its natural state, is going to be 0. Similarly, you can put this as you can find delta H information for H2, I2, Br2. Those are also 0 as well. So part B, they want to write the chemical equation for the reaction whose enthalpy changes standard enthalpy formation of sucrose. So the way to solve this is to first we're going to put our sucrose on the right. It's C12H22O11. And we're dealing with solid sucrose here. So the equation for the reaction whose delta H is the standard enthalpy of formation of sucrose, that's actually going to be the individual elements in their standard states coming together to form sucrose. Because remember Hess's law. Delta H reaction equal to delta H products minus delta H reactants. So our product is going, the delta H of product is going to be the delta H of formation of our sucrose here. Here, delta H of reactants, that's going to be the sum of the delta H values for elements in their standard state. And remember, the delta H for elements in their standard state, that is going to be 0. So delta HR is going to be 0. So that means that delta H of reaction for this chemical equation is going to equal the delta H of our products, which is going to be equal to delta H of formation of our sucrose. So let's get started. So we have 12 carbons on the right, so we have to have 12 on the left. Left. Now we're going to add our hydrogen. And our O2. So now we have 22 hydrogen on the left, and 22 on the right, 2 on the left. So we're going to put at 11 right here, because 11 times 2, that's going to give us 22 in total. Now we have 11 oxygen on the right and 2 on the left. So we're going to put the fraction 11 over 2, because 11 over 2, that is going to equal as 11 over 2 is going to equal times 2 is going to equal 11. Now, needless to say, you cannot have half a molecule. It's just a way we can understand this kind of reaction, because the delta H of formation for sucrose, or any sample in general, that only works if you're producing 1 mole of your sample. If you're not, then you're going to have the wrong delta H of formation. So that's why we have to have 11 over 2 O2 molecules. It's not that we have half a molecule. It's just more of a mathematical representation to understand and how we can have us find the delta H of 1 mole of sucrose. And that's how you solve this basic setup. Remember, or just to recap, the delta H formation of elements in their most stable form, that is always 0. And when we want to find the delta H formation of a specific sample, the chemical equation we're going to be using is elements in their standard state coming together to form 1 mole of our product.